This is Professor D. Gokila from Christy Jayanti College, Bengaluru. So this is nothing but a dimensionality reduction project that is used in machine learning. So dimensionality reduction, dimensionality of input. The number of observables is used as an input in dimensionality reduction. For example, age, income, etc. If the number of observables is increased, that is a more number of time to compute, more memory to store inputs and intermediate results, and more complemented explanations, the knowledge from the learning regressions with parameters, and no simple visualization need more much data for dimensions. The dimensionality reductions can also be used in such a way that some more features bear little or non-useful informations. For example, the color of hair for car selection can drop you some features that have an estimate with the features can be dropped from the data. Several features can also be combined in dimensionality reduction in such a way that there is no loss or even a gain of information. For example, income of all family members of a loan and application, where some features can be combined together, where some features can be estimated the cost and reality of a particular family income. For the dimensionality reduction is mainly used for future selection extraction. What is future selection? Future selection is an important concept in machine learning where it is used for important futures extractions, where the formula used is dimensionality reduction minus k. That subset selection algorithms are used. Future extraction projects the originals and dimensions k less than d dimensions, where we have principal component analysis, linear discriminant analysis, and factor analysis. The usage of dimensionality reduction. Have a dimensions of D, reduction of dimensionality expressions, discard the unimportant features, combine the several features in one. The resulting the k-dimensionality data sets for learning the classification problem, the parameters of probabilities, learning for a regression problems, the models with a theta is used. Subset selection. Have an initial set of features of size D. Have 2 into D possible subsets. Need a criteria to decide which subset is the best one. A way to search over the possible subsets. Cannot have 2 into D possibilities. Need some heuristics. Goodness of a feature set. Supervised set and unsupervised set. Training can be selected using a subset, estimated error and validation data set. Unsupervised is used at an input such as age, incomes, and savings. Select subset of 2 that bears most of the information about the person. Mutual information, which gives 3 random variables and have to select which of the most information. If x and y are correlated, then much of the information about a y is already in x. Most sense select features which is uncorrelated. Mutual information is more general measures of mutual information. It can be extended to variables with many causes of x power n plus 1. Subset selection. We have forward search and backward search. Forward search start with a 70 set of features, try each of remaining features, estimates classification and regression errors for adding specific features, selecting feature that gives maximum improvement in validation errors, stop no significant improvement. So backward searches start with the original set of size D that drop features with small impact factor called as error. We also have floating search. The floating search is used in such a way that the forward and backward algorithms are used with greedy approaches. It selects the best operations at the single step and it don't always achieve the optimum value. Floating search is a 2 type of steps that add and remove the k with more computations. And also the future extractions are used in such a way that it can face the recognition problems, training the input data with labels and classifiers as the input image and classifier output as a label name. So we have the matrix of 256 into 256 values here. Each pixels bear little information, so cannot select 100 best ones. Average of pixels around specific questions give an indication about eye color. We have the projection z is equals to wtx. Find the projection matrix W from dimensional day to k dimensional vectors that keeps the error low. PCA motivation that assumes D observables as a linear combinations of KD factors. With all the Z values, we would like to work with biases as its lesser dimension have almost required informations. What we accept from such biases, uncorrelated or otherwise, can be reduced further, have a large variances. This is a PCA motivation algorithms. So data directions have a total variance of data with maximum. Maximize the total variances. Choose directions that can be orthogonal. Minimize correlation. Choose k minus j orthogonal directions with the total variance. Choosing only directions. Eigenvector. And this is D stands for dimensional space feature, and D by D is a symmetric covariance matrix estimated from samples. Select a largest eigenvalues of covariance matrix and associated eigenvectors. The first eigenvectors can be the direction with the last variance. So this is what the output of PCA with columns and eigenvectors that has been present and centers that the data are originally rotated with an axis. Thank you all for listening this one.